My dear students, I am Dr. Gunasegaran, who is going to take NEET question paper discussions. Vetri welcomes you all. Today, we are going to discuss Unit 3, that is chemical bonding and molecular structure. Part 1 we have discussed already in the previous video. And today, I am going to discuss the second part 2. So, NEET original question papers asked between 2022 to 2025 will be discussed by me now. So, before starting, I want to give one important information. To answer all the questions asked in the chemical bonding, you must know the following subtopics. Very clear idea. Ionic or electrovalent bond. Under this, what is ionic bond? What are the characteristics? Then the Fajan's rules, and then we have to think of lattice energy. Coming for covalent bond, this is very most important because entire organic chemistry is based on covalent bond. So there are different theories are included: Ogden theory, Sedgwick Bowl theory, valence electron pair repulsion theory, valence bond theory, valence bond orbital theory. The next one, molecular orbital theory. So we must know all these things because question may be asked. Then third bond, coordinate covalent bond. Specific example, ammonium ion formation, ammonia plus H plus giving ammonium ion, coordinate bond. Then metallic bond, hydrogen bond. So only if you have a clear idea without any doubt, you can answer all the questions asked in the NEET. Now, today I am going to discuss the NEET question paper, that is under this part 2, so 7th question I am starting. It is asked in NEET 2023, given within bracket. Question is, the correct order of energies of molecular orbitals of N2 molecule is. So what they are expecting, you must know the energy diagram for nitrogen molecule, how nitrogen molecule is formed. So what they are given here as a solution, the option is given as, that is 4 options are given. Option 1, option 2, option 3, option 4. If I read, it will take time. So instead of reading and deciding, then they have given already it is a nitrogen molecule. Better we will go for nitrogen molecule and look for the energy level diagram, and from that you have to decide. So before going for the explanation of this, to understand the questions, let me give a short introduction regarding molecular orbital theory. What is molecular orbital theory? The atomic orbitals present in the valency of an atom will undergo chemical combination with atomic orbitals or valency cell of atomic orbitals of another atom combined to form molecular orbitals. So, total number of molecular orbital formed is equal to total number of atomic orbitals combined. So, once molecular orbitals are formed, there are 2 types. One is bonding molecular orbital, another is anti-bonding molecular orbital. Bonding orbital is lower in energy, anti-bonding orbital higher in energy. So, electron present in bonding molecular orbital will be forcing the bond formation, will induce bond formation. Electron present in the anti-bonding molecular orbital will reinforce, that we will oppose the bond formation. This is the most important. The most important information I want to give regarding the molecular orbital theory, one of the concept is, what is bond order? Bond order is equal to the total number of the electrons present in the bonding molecular orbital, normally low energy, minus the total number of electrons present in the anti-bonding orbital, higher energy, divided by 2. you will get the bond order. The most important information, if bond order is 0, the molecule will not exist. So we can, with the help of molecular orbital theory, we can find out whether a particular molecule exists or not. This is the information. So here we have to restrict only with the nitrogen, even though as the first question, I will explain some 2 to 3 molecules for your information. So this is the boron molecule. Kindly follow. Suppose if suddenly asked whether B2 is available, you can say no, it is not possible. But with the molecular orbital, if you try, then you can say it is possible. How? Let me look the diagram. We know the boron electronic configuration is 1s2, 2s2, 2p1. This is the electronic configuration. So only the outermost valence shell is 2s2, 2p1. So there are 3 electrons are there, 2s2, 2p1. So we have to consider only 2s and 2p. We have to consider. Kindly follow. So we need not worry about the 1s. So what will happen now? When I already told you total number of s orbital combined to give 2 s orbital, p orbital combined will give 2 p orbital, like that. So now when you come for 2s and 2 sigma star 2s, sigma to 2s. So bonding low energy, anti-bonding high energy. So 2 electrons on the boron 1 atom, another 2 electrons, so totally 4. The grounding 2 and anti-bonding 2, bonding 2. So bond order is equal to, in this case, 2 minus 2, 2, it is 0. 0 by 2, 0. That means up to 2s, we need not worry. So better is, according to my version is, better you go for the outermost. Go for outermost. What way? Kindly follow me. I am now taking the boron 2p1. Please follow. 2p1 I am taking. So left side 1 nitrogen, right side 1 nitrogen. So 1 is here. So here we have to assume now p orbital, there are 3 p orbitals. What are the 3 p? For your information, I will give now. Kindly follow me. One is, this is 1 orbital. This is another orbital. This is another. This is p orbital. So there are 3 p orbital. In the energy level diagram, conventional method, we will draw like this. 3. So this is the actual diagram. So now, this is the molecular axis. Please follow. Only through this molecular axis, that means only through this orbital overlapping will form. This is according to valence bond orbital theory. 1 orbital SS overlapping gives sigma, SP overlapping gives sigma, and PP head to tail overlapping will give sigma, and p orbital head to head, tail to tail, that's called lateral overlapping, will give pi. This information you must know regarding the hybridization. Now come for molecular orbital, right side 1 electron, left side 1 electron. So our total orbital 3, here also 3. So 3 plus 3 combined total is 6. So bonding molecular orbital 3, anti-bonding molecular orbital theory. Now the students, you must understand here, bonding will be low energy, this is the energy level, here lower to higher level. So low energy bonding. So by 2, here you have to fix now one important thing is, that means you have to think of what axis you are going to keep, the x-axis or y-axis. Kindly follow. X-axis or y-axis. From that only we have to decide. So according to this, kindly follow. Now, x is the molecular axis. So there are 3, that is through which it is bond formation. Y and Z are the between the axis. Kindly follow. Kindly follow. This is along the axis, the other two will be px, py, pz. So in this case, only pz we have one orbital. Here p is a x, y. So here it is given one electron. Okay. So when you are combining, now what I am taking is the energy level, that this is y, this is z, this is x. That means molecular axis is y-axis, only through which bond will form. So how many electron? 2 electron. So now one important information, as in the case of atomic orbital, when we are filling up electron, we are filling lower level to higher energy level. In this case also, the same rule formed. Low energy pi orbital. So 2 electrons are there. They are equal in energy. So 1 here, 1. That means pi to x, y will occupy 1 electron. Pi to z occupy 1 electron. 2. So antibonding, there is no electron. Sorry, pi 2 that is sigma 2px, there is no electron. So what is the bond order? Bond order equal to, so total number of electron present, bonding molecular orbital 2, antibonding 0 by 2. So answer is 1. That means B2 molecule, it is existing. So we are proving that the boron molecule is existing. The bond order is 1. Please follow. The same way, now I will go for the carbon also. Please follow the carbon also. Between carbon C2 molecule, is it possible or not? It is possible because as in the previous case, kindly follow me. As in the previous case, you look here, only this is the carbon. Please follow. As usual, here y is that, here x, that is sigma. Then antibonding here sigma star 2px, pi star 2py, pi star 2pz. So how many electron in the carbon? 2s2, 2p2. So 2p2 actually 2s2 completely filled. So bonding and antibonding, so net effect is 0. So you consider only p orbital. So right side 2 electron, left side 2 electron, totally 4 electron I am filling up. So first orbital 1, second orbital 2, then again 3, 4. So lower pi orbital filled, whereas sigma orbital is not filled. That is px is not filled. Now what is the bond order now? The bond order is equal to total number bonding 4, anti-bonding 0 by 2. So answer is 2. So carbon C double bond C, it is existing. So we are proving that C2 molecule is forming. The same way, now we come for our nitrogen. Please follow. Question asked in nitrogen. In the nitrogen, as usual, we need not worry about 1s, 2s because completely filled, so we need not worry. Or generally, the sigma star will be greater than sigma. So only we have to concentrate pi. Please follow, only pi. This is in the case of nitrogen molecule. Nitrogen means, you know already, 2s2, 2p3, the electronic configuration. So I will consider only p3. That means the right side 3 electron, left side 3 electron in nitrogen atom. Whereas in the nitrogen molecule, so lower is 3 plus 3, 6. So all the 6 electrons occupied in the bonding molecular orbital. In the antibonding, there is no electron. So for in this case, what is the bond order? Bond order is equal to bonding electron 6, 6 minus 0 by 2, it is 3. That's why nitrogen is having triple bond. 1 sigma and 2 bi bond. What is the interesting information here is, kindly follow. Starting from this, here pi to pi, pi to p is that, and sigma to px, the level is increasing. The next comes sigma star to px, then next come pi star to px and pi star to pz. In this case, x is the molecular axis. Kindly follow. And here, now we will go for the question now. Kindly follow. The question is, so now answer we have to think of. Now let me go for the answer. Now here, now this is, wait a minute, we'll go for the question now. Okay. Now just see here the 1 to 4. Lower, automatically we have to go at the top only, because lower always 1s sigma, the sigma 1, wait a minute, I will take now, I will take here, this is the case, because let me take this example, but with yellow color, don't take it as a correct one, it is wrongly given. Anyhow, let me explain now. So when we are going for the highest level, what we have discussed here, this is the order. That is, this is the order we have discussed. Kindly follow. This is sig pi 2 py. And here we have to see that what is the sigma? That is the most important. So sigma means, here molecular axis is z axis. So this is z, p z. So this is yx, this is y, px, py. That means pi to px, pi to py here. So when you go here, the last one at the top here, you consider. What is here? Pi, that is, Z is considered as a molecular axis. So X and Y should be the highest level. Then see the top, the number 1. So it is not correct. Then number 2, sigma star, it is not correct. Then see here, sigma pi to px equal to pi star to py. So this probably the correct answer. Kindly follow. How I can now come back? You just think of the diagram. Sigma 1 star greater than 1. Sigma means antibonding. The same is 2 star sigma s, 2s greater. Then 2 pi z, that is the molecular axis, greater than 2px. This is star. Then coming over here, pi 2px equal to pi 2py. This is the lower level. It is the filled, actually filled. Coming for here, pi, it is also here, pi px equal to pi star py. Kindly follow. So pi star 2px equal to pi star 2py at the last one. Kindly follow. At the last one. So the correct order here it is. This is the correct order. Kindly follow. 3 will be the correct order. Very, very interesting information you have to think of. Okay, answer is 3. Okay. Now question number 7. Now here, kindly follow. Match the list 1 with match list 2. List 1 is, they are given 4 molecules. A, ethane, B, ethene, C, carbon C2 molecule, D, ethine, acetylene. And this list 2, number and types of bond. Number and types of bond, sigma or pi. Between 2 carbon atom only. That is right side given. So what you have to do? This they have options are given. If you look the option, you will be getting confused. For that, you have to work out. What way? See my working method. So I am taking first ethane. Ethane means carbon-carbon single bond. This is the structure. This is the structure. Kindly follow. So carbon-carbon, one sigma bond is present. This ethane, kindly memorize one sigma bond. Coming also, I will write here one sigma. Then coming for ethane, I can write CH2 double bond CH2. So here one sigma and one pi. There are two bonds are there. One sigma and one pi. In ethane, one sigma and one pi. This is as per the valence bond, the hybridization concept. We can define valence bond orbital theory also we can identify. This is second one. And third one is carbon 2 molecule. I told you already carbon double bond, both are 2 pi. There is no sigma. We have discussed already carbon molecule. The lastly, ethane means acetylene. In acetylene, there is between carbon, this is acetylene. That means 1 sigma, 2 pi bond. This is the answer. So this, keeping this mind now, we now correlate what is the correct answer. See here, now I am going to correlate. Ethane 1 sigma. Just see where is 1 sigma? 3. 1 sigma. Ethene 1 sigma and 1 pi bond. Where it is? 1 sigma, 1 pi bond. This is ethene. B4. Next, carbon 2 molecule. 2 pi. It is 3. The last one, ethane 1 sigma, 2 pi. It is the 1. So answer is, I can write now A3, then B, B4, B4, C, the C is 2 pi bond, that is 2, and D, it is 1. Now it is easy. Compare now option given. 1, 2, 3, 4. A3. Where is A3? Only 2 and 3 will have A3. The next one, B4. Both having B4. So we cannot able to differentiate. Then C, 2. This is 2, this is 1. So answer is 2 is the correct answer. So instead of comparing simply values, you predict with the help of the molecular structure, you predict. Answer is 2. Kindly follow. Answer is 2. The next question, I can now go for next question. I will take now. Question 9 is, okay, question 9. Kindly follow. Intramolecular hydrogen bonding is present in A, that is paranitrophenol. This is metanitrophenol, 3HF, 4 orthonitrophenol. This is the structure. In one of these molecules, intramolecular hydrogen bonding is present. So for that, what do you need? You must know what is hydrogen bond, how many types, what are the characteristic property. So let me explain now. Kindly follow me. So hydrogen bond, when a hydrogen atom is placed between two electronegative atoms, then the force of attraction between hydrogen atom and the non-bonded more electronegative atom is called hydrogen bond. Please follow, there should be hydrogen. That hydrogen will be connected by bond one side, by dot another side, force. There may be oxygen. So this force, we will call it as hydrogen bond. Okay, I will explain with the example. For information, the strength of hydrogen bond is about 20.8 kilojoule per mole. Okay? Now, let me go. As per I already informed you, there are two types. One is intermolecular hydrogen bond, intramolecular hydrogen. What is mean inter? Inter means between two molecules. Here, within a molecule. Intra, within a molecule. That is the difference. So let me explain with the example. See, this is the intermolecular water. This is the water. If you take, what is the molecular weight of hydrogen water? H2O. So as per the rule, basic concept we have discussed, you must know that 18 grams is the molecular weight. 18 grams, as per the concept, will contain 6.023 into 10 to the power of 23 water molecules will be present. 18 grams. So many molecules. So if it is so many molecules, now two molecules will form one bond. This is the hydrogen bond. So N minus 1 bond will form. N is the total number. 6.023 10 to the power 23 minus 1 hydrogen bond will form in 18 grams. Okay. Now we forget about that. Now this is the definition. Let us say now, when a hydrogen is placed between two electronegative atoms, when hydrogen is placed between two electronegative atoms, the force of attraction between hydrogen and non-bonded more electronegative atom is called hydrogen bond. This is called intermolecular, between two. I go clear? Now we'll go for intramolecular. What is meant by intramolecular? Within a molecule. This is orthonitrophenol. I am writing structure like this. So what will happen now? In NO2, N double bond O, it is very close to the hydrogen atom. The 6 membered ring is there. So let me put a number here. 1, 2, 3, 4, 5, 6. So now 6 is hydrogen. Let us assume now. So now it is between two oxygen. One side through bond, other side through force. So it is also hydrogen bond. But what is there? This is within a molecule. So intra. What is the characteristic properties? Example, this is the most important. My dear students, you kindly note this. Compounds containing intermolecular hydrogen bonds will be having high melting and boiling points, whereas compounds containing intramolecular hydrogen bonds will be having low melting and boiling point. Very, very easy. So with this idea, now we'll go for the answer. Question is, intramolecular hydrogen bonding is present in orthonitrophenol, because then only it will form intra. When you go for paranitro, when you go for metanitro, it will not form a ring-like structure. That is the answer. Next question. Question number 10. Kindly follow. It is given in terms of statement. Given below are two statements. Statement 1. A hypothetical diatomic molecule with bond order is 0 is quite stable. So I already informed you in the previous question, according to molecular orbital theory, bond order is 0, that will not exist. Bond order is greater than 0, that will exist. So here it is given statement with the bond order 0 is quite stable. So it is wrong. It is wrong. Statement 2. As bond order increases, the bond length increases. Please follow. This is also wrong. So by reading the statement itself, we can fix. Then we have to go the option given below from that. Let me explain what is the between a bond order and bond length combination. I will explain. Then I will come for the again question. For that, please follow bond order equal to 1 by 2 into total number of electron occupied in bonding molecular orbital minus total number of electron occupied in the antibonding. So bond order is now here. If bond order decreases, bond length increases. So here bond order decreases, bond length increases. So ethine, kindly follow, bond order 3, ethylene bond order 2, ethane bond order 1. So what is the now what we can assume now? When bond order increases, bond length decreases. Bond order decreases, bond length increases. So please keep in your mind. Bond order decreases with 1, bond length will be increasing. Carbon, say for example, ethane, carbon-carbon bond, ethylene, carbon-carbon double bond, triple bond, carbon triple bond C. So here, this is the case. So please follow. Bond order and bond length are reverse order. Bond order increases, bond length decreases, vice versa. So with this information, now we will take the statement 1 is the correct. That means both statement 1, that is a hypothetical diatomic molecule with bond order 0 is quite stable, it is wrong. And statement 2, in the light of above statement, that is a bond order increases, bond length decreases. No, increases, decreases. So both statement 1 and 2 are false. This is the correct answer. The next question. Kindly follow. Identify the correct orders against the property mentioned. Here there are 4 options are given. And the option 4, again they have given some different property. One is dipole moment. Number 2, lone pair on the central atom. Then bond length. Then bond enthalpy, that is bond energy. So you should be carefully analyze and identify. Among the first one, dipole moment. What is meant by dipole moment? Mu equal to product of distance into charges. Q, product of distance between 2 atoms and the charges, difference in charges, that will give the mu, dipole moment. So dipole moment, it is a periodic property, you must study, so that what we can say, normally say for example O2, dipole moment 0, Cl, all diatomic molecules, all diatomic homonuclear diatomic molecule, dipole moment 0. When you go for heterodiatomic molecule, dipole moment varies, HCl, HBr, like that it will vary, HF. It will vary. So the idea here it is based on dipole moment. So if you go for dipole moment, water is having higher dipole moment, it is very, very high, nearly almost 1.8 to 9, approximately 2, then comes NH3. So this is correct. A is correct. Then coming for B, Xe4, Xe03, Xe42, number of lone pairs. Now this we have to work out. What we have to work out? Kindly follow. X we have, let me explain now. What is X? 5s2, 5p6. 5p6. So in terms of the diagram, This is 5P, 5S. So here S2, S2 both filled. S2, 5S, 5P and 5D empty. 5D empty. Now what you have to think of? XC4 means 4 sigma bond. XCO3 means 6 bonds are formed, 4 the sigma bond, 1 pi bond, 2 pi bond. XCF2 means automatically the only 2 linear molecule. So number of lone pairs it should be, in this case, you just think of XF2 means one of these electron getting excited here, so 2 bond will form. So lone pair 1, 2, 3, 3 lone pair will be present here. In XCF2, 3 lone pair will be present. Only 2 bond will form. Here what is given? Number of lone pairs on central atom. Lone pair, it's so automatic, this is 3. Then XO3 means 6 bonds will be 6. In that case, P3 and D3, so it will be sp3 D3. So one lone pair it is present. In X4, all the 6 here, sp3 D3, sp3 D3. So only one lone pair. Then XC4, there are 2 lone pairs. So this is wrong now, because XCF2 should be the first one. So this is wrong. Now coming for the bond length, OH, CH, NO. Which is the correct order? Because when you compare to OH and CH, NO, order is not correct order. Because when electronegative atom is present, that hydrogen will come closer, where if it is less electronegative is more. So bond length, this should be greater. CH should be greater than OH. So this is also wrong. Coming for the bond enthalpy, energy, so this is correct. How? Bond energy, this is 3 double bond, 3 bond, this is 2 bond, 1, this is one bond. So higher the bond energy, higher will be the energy. So answer should be A and D will be the correct answer. Kindly follow. So here I have already explained here, kindly follow. H2O 1085, ammonia 1.47, chloroform 1.04. The first A correct. Then coming for D, it is correct, shown in yellow color. I hope you understand. The next question number 12. Question number 12, kindly follow. Match list 1 with list 2. So they have given list 1 molecule given, XCO3. Wait a minute. XCO3 it is given, XCF2, XCOF4, XCF6. In all the cases, now we know I have written already, it is 5S2, 5P6 and 5D0. This is the electronic configuration of the helium, neon, argon, krypton and xenon. Helium, neon, argon, krypton and xenon. So what will happen now? We from the actually the bond formation in this nature, we can assess. Here XCF6, that is 5S2, I will write here follow. 5S, 5P3 and 5D5. So that is S2 completely filled, P6 completely filled. What will happen now? In order to form 6 bond, 3p electrons going to the 3p d orbital. 3s, 5s, 5p, 5d. So now I can represent now one pair, single electron, single electron, single electron, single, single. So hybridization is sp3d3. Just see where it is. sp3d3. So this is going here. sp3d3. Why getting distorted? It should be shape is octahedral. Why it is distorted? One lone pair is there. It is getting distorted. Then same way, you go for now the first one A. Why I have taken this? All sigma, that's why I have taken first for your understanding. Now let me go for XeO3. Again 3 into 2, 6 electron again is going there. And here also, kindly follow me. Here 2 pi bonds are there and 2 sigma. 2 pi bond, kindly follow. X is there, Xe. There are 3 electrons, so 2 pi and 2. This is XO3, structure of xenon trioxide. So in each case 1 sigma and 1 pi. There are 3 sigma, 3 pi. So as per the valence bond theory, pi bond will not taken into account for the shape. Will not. But hybridization is sp3d3. That is okay. sp3d3. But this will come. There is one lone pair is there. So this is trigonal. Kindly follow. Just like ammonia structure. Xe, one, another, a lone pair is there. Imagine now. This is O, this is O, this is O. Lone pair from 5s. So that means hybridization is sp3, that is the d2 square pyramidal. Hybridization sp3, but this is square pyramidal. sp3 pyramidal. It is sp3 pyramidal. sp3 pyramidal, because only 3 bond, sp3 pyramidal. Because 3 bond, 3 sigma, so sp3, actually it should be the 2 pi bond also it is present there. The next one, XF2, it is linear. sp3d, only 2 bond, it should be linear. So automatically XeFO4, we should be actually, it comes for the 4. sp3d2 square pyramidal. 4 sigma bond square and oxygen a pi. So the shape will be, what is the shape? The X will be here. 4 oxygen will be here. Then the pyramidal will be, kindly follow, let me show now, X, the Xe, F, this is the shape, O. So square pyramidal, sp3d2 square pyramidal. So now I can easily say XO3, it is Xe2 linear, one is Xe2 linear, so X3 linear, X3 so Sorry, this is